In question 12, we're given 15 measurements that we need to find x bar m in the mode for. Just like we did before, our first step is going to be writing them smallest to largest. So as I look across my list, the smallest number that I see is 54. I'm going to start with 54. Next smallest number that I see is 55. I see two of them. 55, 55. I'm looking for any 56s. I don't see them. I see 1, 2, 3 57s. 1, 2, 3 57s. I'm looking for 58. I don't see any. I see 1, 2, 3, 4, 5 59s. So 1, 2, 3, 4, 5 59s. Cross those off. 2, 3, 4, 5. Then I only see 1, 2 61s. A 62. And a 63. Just to double check that I got everything, I'm going to count to make sure my new list has 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now that I've got everything in order, I'm going to add it all together and divide by 15 in order to figure out what the mean is. So I'm putting into my calculator 54 plus 55 plus 55 plus 57 plus 57 plus 57 plus 59 plus 59 plus 59 plus 59 plus 59 plus 61 plus 61 plus 62 plus 63. When I add that all up, I get a total of 877. I'm going to take that 877 total, divide by the 15 data points that I had. When I divide that by 15, I get 58.4666 repeating. I'm going to call it 0.47. Always go to whatever decimal place it tells you to round to. I didn't write anything down here, so I'm just going to 2 decimals, but they should give you a number of decimal places to round to. When I go to calculate the median, I start with the position function. The position equals n, in this case 15, plus 1 divided by 2. That's 16 divided by 2, or 8. So I'm looking for the 8th data point in the ordered list. 1, 2, 3, 4, 5, 6, 7, 8. 8th data point equals 59. So 59 is my median. When I go to calculate the mode, I look for the thing that happens the most. 59 occurs 1, 2, 3, 4, 5 times, which is more than anything else. So my mode is 59. It's a unimodal distribution because there's a single number that happens the most. In question 13, we're asked to calculate variance and standard deviation. So we're given n equals 8 measurements, 1, 1, 2, 2, 3, 2, 4, 4. First thing we want to do is calculate the mean, or x bar. So I'm adding together 1 plus 1 plus 2 plus 2 plus 3 plus 2 plus 4 plus 4, and I'm going to divide all that by 8. When I put it into my calculator, 1 plus 1 plus 2 plus 2 plus 3 plus 2 plus 4 plus 4 gives me a total of 19. Divided by 8 gives me a total of 2.375. So I got 19 divided by 8. I'm going to call that 2.375. You might be tempted to round this 2.375 to say 2.4. My recommendation is not to round as you do this process. Only round at the last step where they tell you to do it to 4 decimals. I know that makes it a little tougher as you go along, but that way your answer will match what they want. So now I have to take each individual data point, 1 minus 2.375, square the result. I'm going to do this twice. Then I'm going to do 2 minus 2.375, square the result, do that 3 times. 3 minus 2.375, square the result. I only have one of those, and then 4 minus 2.375, square the result. I have 2 of those. So I'm going to put each of them into my calculator, first how they are, and then multiply by whatever's in front. So if I do 1 minus 2.375, and I square the result, this gives me 1.890625, which I'm going to multiply by 2, because there's twice in my data set that I have the number 1. So when I multiply that by 2, I get 3.78125. When I do the same thing, except now for 2, 2 minus 2.375 squared gives me 0.140625, which I'm going to multiply by 3. When I multiply that by 3, I get 0.421875. When I do this for 3, here I'm only going to do it once because there's only one data point that's 3. This gives me 0.390625. Finally, I'm going to do it for 4. Originally, when I do 4 minus 2.375 and square the result, I get 2.640625. I'm going to multiply that by 2. So that gives me 5.28125. Again, the reason that I'm multiplying these is because I have the same number appearing in my data set multiple times. If they were all different numbers, I'd want to show each individual data point being squared. Here I'm just trying to save time by saying this is occurring this many times. So now I have these numbers that I need to add together. When I get the total of them, I'm going to add together 3.78125 plus 0.421875 plus 0.390625 plus 5.28125. That gives me a grand total of 9.875. So that 9.875 is the top of my formula, the sum of the squares. I now need to divide it by n minus 1. So in this case, that 9.875 is going to be divided by 8 minus 1, or it's going to be 9.875 divided by 7. When I put that into my calculator, divided by 7, I get 1.4107142286. But it specifically asks me 4 decimals. So I'm going to look at what's in 1, 2, 3, 4th decimal place is this 7. After the 7 is a 1, so I can just drop it. That means my final answer is going to be 1.4107. If I now take this final answer and I put it in for the second question, it's the same exact answer. So when you're doing this s squared by one method and then by a different method, all I really want you to be able to do is this single method. It'll be the same answer for part A and B. That said, if you put in the answer for A and it's wrong, that tells you something went wrong, you should put in something else for B. When I now am asked to calculate S, I should take the square root of my answer, in this case 1.4107. When I put that into my calculator, the square root of 1.4107, my answer is 1.1877. In this case, it says round to 3 decimals, so we're rounding to this digit. Since what we're dropping is 5 or more, we round up, and we end up with 1.188.